Hey guys, so today we talked about how to do a binomial distribution using Google Sheets. Um, so in class we did the check for your homework last night, page 131 question 1 and 131 question 2. And so I will be doing the binomial distribution from your homework, from the worksheet homework from 2 nights ago. So this is about the basketball shooting robot that has an accuracy of 85%, and the robot takes 8 shots. So again, the first step is defining the variables. So in this case, our n is 8 because the robot takes 8 shots. Our success is basically if the robot makes the shot. In this case, it is 0.85. And my Q, the probability of failure would be 0.15. The other way to make sure that this Q is absolutely correct is if I do 1 minus whatever P is, right? In this case, P is 0.85. This gives me 0.15. And so now we need to construct our binomial distribution. As usual, our x is a range from 0 to 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And our px would be our formula for the binomial probability. Recall that the formula, you should have it written in your books, is n divided by n minus x times x. So this is the first part. This is the combination of n choose x, is how you would say that, multiplied by p to the power of x, multiplied by q to the power of n minus x. So remember that this is our formula. And so we would need to convert this to something that Google Sheets can understand. So first we'll start with the fraction, with our combination. In this case, the exclamation point is a factorial. So in this case, it would be equal to fact. And what is important is the parentheses. Make sure that your parentheses are all in the right places. And if you don't want a variable to change, don't forget to put your $signs. In this case, my n is in A7. I don't want this to be moving. N will always be at A7, so it's really a $7. And I want to do the factorial of that. So factorial $7 divided by parentheses, again, $7 minus our x, which is in A11. This time, I do want the x to be changing as I move through the list. And I forgot to put factorial, so I will go ahead and do that. Factorial of n minus x multiplied by factorial of x, which is in A11. So one way to check this is the small blue number here should be equal to 1 if you are starting at 0. This is a good way to just check that you are doing your division correctly. Next up, our P is in B7. Again, I don't want this to move. So B $7 to the power of x, which is in A11. Multiplied by my Q is in C7. Don't want it to move. C $7 to the power of n minus x. So a $7 minus A11. I can choose to autofill this. If you don't want to autofill, or if it doesn't pop up, you can click this blue square and drag it down. in this case, we can see that we have a lot of decimal places. And we usually don't really want to have this many decimal places. One thing you can do is select your probabilities, and then up here, there's an increase and decrease decimal places button. So I can decrease it until I have, I would say for this one, 5 decimal places is okay. As long as you're anywhere between 2 and 8 decimal places, it should give a pretty good number. And so now we have our probability distribution. So today we also learned about the mean, the variance, and the standard deviation. So the formula for the mean is n times p. The formula for variance, n times p times q. And the formula for standard deviation is the square root of the variance, which is square root of n times p times q. So unlike the probability distribution, for a binomial distribution, the mean, variance, standard deviation is pretty easy to calculate. So in this case, I will go ahead and do so. My mean is my n multiplied by my p, so equals a $7 times b $7, which is 6.8. My variance is a $7, that's where my n is, times b $7 times c $7 gives me 1.02. My standard deviation is the square root of the variance, so equal the square root of my variance, which gives me 1.0, basically 1. So now we can answer some of these questions on the side, right here. So my first question is, what is the probability, what is P4? In this case, P4, if we look, is 0.0185. So about 0.018 or 0.018 is a fine answer. You can also answer 1.88%. Both answers are acceptable. What is the probability of exactly 7 successes? Well, in this case, 7 successes is right here, 0.384, 0.385, or 38%. In this case, I'm just going to answer as decimal, 0.385. I'm going to round it to 3 decimal places. Next up, what is the probability of less than or equal to 5 successes? So if we look here, the numbers less than or equal to 5 are 0, 1, 2, 3, 4, 5, right? So that means that I want to add up all these probabilities to find what is the probability of everything less than 5. I can add these up manually using a calculator, or I can do sum of, and then I can click and drag this whole set, right? So everything from 0 to 5, that will give me about 10.5%. Again, I'll answer in decimal, 0.105. Probability of more than 2 successes. I'm just going to delete this one and I'm going to restart. More than 2 successes is everything bigger than 2, but it doesn't include 2, right? 2 is not more than 2. So I will need to start at 3 all the way up to 8. That gives me 99%, about 0.999. Since it's a probability, I don't really want to round it up to 1, because that means that it's a 100% chance, right? In this case, it's not really a 100% chance, so I'll just leave it at 99.9%. The probability of between 3 and 6 successes inclusive. So in this case, inclusive means that we include 3 and 6. So everything between 3 and 6. about 34%, 0.343. Now, what is the average number of successes that the robot builder can expect from the robot? So if you built this robot and you know it has an accuracy of 85%, how many shots can you expect it to make, right? In this case, remember that the average number is basically our mean, right? That's our expected value. In this case, 6.8 is the number of shots it can make. You can't really make 0.8 of a shot, so in this case, we can just round it up to 7. In some cases, you can leave it as a decimal place, and that would also be fine. The second question, the most likely number of successes will be between what two numbers? In this case, it would be 7, our mean, plus or minus our standard deviation, right? So 7 plus or minus 1. 7 minus 1 would be 6, and 7 plus 1 would be 8. So the reason we do this is because it is not really realistic to expect exactly 7 shots every time, right? There will be some errors here and there. So this is giving us a range of what we can expect most of the time. We'll learn about the exact number of times later on, but for now, just know that this range gives us most of the time. So each time that the robot takes 8 shots, most of the time it will make anywhere between 6 and 8 shots. Of course, there will be outliers. You can't score more than 8, so there won't be any outliers that way. But there may be times where it shoots 5 shots or 4 shots. Those are all possibilities, but most of the time it would be between 6 and 8. So that pretty much about sums it up for what we did today. Again, if you want more practice, you can do in-class practice 2. You do need to define your variables. This is important. Make sure you define your N, P, and Q, and then try to answer these questions. I will be posting the answers tomorrow. So if you want to check if you did it correctly or not, you can do that. If you want to just make a copy so that you can look at it after you turn it in or change some things or just play around with it, you can do so. Remember that your homework is this one. Again, as I was showing in class, in this case, N is equal to 50, right? There are 50 students. For your random variables, you could type in one, starting from 0, 1, 2, 3, 4, all the way to 50. The other thing you can do is do equals to the previous number plus 1. And this way it would automatically add things for you. You can drag it, see where you land. In this case, I don't need 51 and 52. So it goes all the way to this, to row 57 for me. It depends on where you start your columns and rows, but in any case, make sure you answer the questions on the side here. And yeah, so just make sure, important things, parentheses, make sure they are in the right place. This is, once again, the formula. You might have put your N, P, and Qs in different places. So make sure that all these symbols, your locations, are where your variables are. Don't forget your dollar signs for N, P, and Q because you don't want those to move. As long as you're careful about your parentheses, you're careful about your dollar signs, then this formula should be able to be used pretty quickly as a way to either calculate probabilities with a large N or just to check your work if you're doing it by hand. So that's everything that we did today. If you have any questions, again, you can email me or talk to me in class, or send it as a comment in our assignment. So yeah, let me know if you have any questions. I'll see you in class tomorrow.